Hi, everyone. Give me 1 second, I'll get started. Okay, so I'm going to be processing NGC 6914. And I was just waiting for the Astro Imaging channel to finish because they had a really interesting live presentation by Gary M. And I thought it was really cool. So yeah, I've already put the files into Cyrillic and I have stacked them. So everything is about ready to go. I was going to do this live, but seeing as though Astro Imaging channel went kind of like long and it still might be going on, I went ahead and closed it because it was the end of the presentation. I thought I would go ahead and get started. So give me 1 second. All right. So let me go ahead and bring up what I have. So I've got a little bit of an image rotation going on. I imaged it over multiple nights, I think about 3 nights. And so my image data aren't exactly lined up, which is fine. But here's the data that I have for my HA for NGC 6914. I probably should have made one of the HA frames the reference frame, but I don't know. I'm a little bit lazy right now, so I'm not going to do that. But the first thing that I would like to do is to go ahead and, hey, AstroUse, how are you doing? Just saw that in chat. Looks like you're in chat, but it's not showing that anybody's on the stream yet. If you just joined, I've got NGC 6914 up. HA is a little bit rotated because I got some image rotation going on. I've got some issues, a little bit of issues here with the flat, with the darks not calibrating out. I'm doing pretty well, I've got some data from a couple months ago that I haven't processed yet, so I thought I would go ahead and stream it. Hey, Eli, how are you? Can everybody hear me okay? I hope so. But if there's anything wrong, let me know. So let me just go ahead and show you what I've done so far. So with Cyrillic, I've put all of my files into the different image sections and I've stacked them already. So I was going to do that on stream, but Astro Imaging channel kind of went a little bit longer and it was kind of an interesting show. So I went ahead and stacked it while it was on. Good. I'm glad you're here. So I guess the first thing I'll do is, maybe I'll go back in here and make the HA a reference frame so it is like not rotated, and the RGB is rotated. But for now, I think I'm just going to leave it because I don't want to have to stack it again. It's already kind of late where I'm at. I'm just going to crop this and try and find an optimal crop here for it. And then we can process the RGB data. Yeah, I guess something like that. I don't know what I would like. I guess I could rotate it, but I don't know if I want to. I don't know if I want to rotate. Let's see, geometry, rotate. Let's see, rotate and crop. It's going to throw off the RGB data, but I guess that's okay. Let's try it. I'm not sure exactly how much to rotate it. I don't want to crop it. Let's see if I can rotate and crop it here. Okay, here, something like this. Probably like that. Nope, wrong way. Something like this, maybe. Nope. I don't know. We're going to just crop it like normal. I was watching the AIC. Yeah, that was a really great. That's a really great presentation. It's something I got to use is the M database, the Gary M's database. It was really cool. See how far we can get over here. I really hate having to crop out so much of this, but we'll just do it for now. I mean, it'd be nice to see how this looks like. Okay, so we've got this cropped. We can go in and do a, oops, background extraction if we want to. It's HA data here, so it's not that bad, but like sometimes I just like to see what happens. Yeah, rotating 0 is hard, I would say. Yeah, yeah, it's a little bit not intuitive. I don't use it too much. Generally, if I do, I would just like do it in Gimp first or something, but whatever. So I'm just going to click a few points where I think there's not very much nebulosity, and we'll see how just the RBF is doing. I don't think I have to put it into Grexpert because I just don't think, I think that the HA data is fine. So yeah, I mean, I don't know. There's not too much. Like I moved since like the beginning of the year, like back in, like we moved in July. So I'm actually in a kind of a darker site than I've been before. So it's not too bad. So I get to go ahead and apply this. And then I think the data is okay. The HA data, I've got about 3.5 hours with that and about 1 hour of RGB data. So hopefully we'll come up with an okay image. Data doesn't look like it has some gradient. Yeah, I don't see much gradient in either. Sometimes I just like to do it. You can see a little bit. Let's do back and forth. You can kind of see if this gets a little bit darker. This maybe is a little bit lighter, and I don't know which one is correct. I think they both look okay. But I actually kind of prefer the RBF one. It looks like this here gets a little bit darker. This gets a little bit darker. So I'm going to keep it with the background extraction. And then we'll see how everything goes. Okay, so I'm going to turn the auto stretch off. And what I think I want to do first, this is the first time I'm actually like processing the data. Sometimes like when I actually put a video, like not a stream, like a video of a tutorial on YouTube, then I will like process the data once and then process it again. And sometimes maybe even a third time, just so like I get what I want. Because usually when I process it the first time, there's always something wrong. Like maybe the stars are weird. I don't know. Something happens. And I go back and I fix it. And then once I fix it, then I kind of do it again with the steps that I did to fix it and trying to make it just a little bit better. It's sort of like, I feel like it's a little bit like taking some inspiration from Bob Ross, right? Like he painted his paintings 3 times. Like he would do it like once before the show, like a couple times before the show, and then like during the show he would paint it again. And that's kind of like what I do when I make a nice tutorial on YouTube. But like for this one, this is like the first time doing it, so it might not be the best, but hopefully we can all kind of like enjoy the process, I guess. Hopefully that makes sense. Okay, so I'm going to turn this into linear. And what I think I want to do is process the HA data without the stars. If I could talk tonight, that would be great. So I'm going to go ahead and do star processing and starnet star remover. Let me just make sure I've got the correct home directory set. So give me 1 second. Yeah, this looks good. Looks good. Correct directory. Okay, let's go and do the star processing then. So go to star processing, starnet star removal, and I don't want to recompose. I just want to have the stars separate. We can recompose it later in Gimp. And I do want to generate a star mask. I do want to pre-stretch the linear image. And then I'm going to go and execute it. And it'll take a couple minutes. So I don't think it'll take a couple minutes. It'll probably take last like 30 seconds. Yeah, here it is. You can see the blue line going here. And it's pretty much done. There it is. Perfect. I think it's okay data for 3.5 hours. There's a little bit of like noise in here. So the problem is like it's been fairly cloudy the last couple of months where there's been cloudy, or like it's been the moon has been out, or it's been not cloudy, but there's been some haze in the sky, and it just hasn't been the best for processing stuff. But I mean, this looks good for 3.5 hours, I think, for HA data. So I don't know if you know, NGC 6914 is actually a reflection nebula, and it's like sort of in here. So the HA data is not going to capture it very well. And so that's not really the focus of the whole thing. I just saw that there's like quite a lot of nebulosity, a lot of like HA, emission nebula around the reflection nebula. And I thought that it would just be kind of interesting, get a little bit of wider field to target with it. So this was taken with a doublet ED refractor. So it was 80 millimeter doublet at 480 millimeter focal length with my reducer on it. So the native focal length of the OTA is 600, and then it's got a 0.8 reducer, which brings it down to 480, and it brings it down from like a f6 scope to like an f4.8 or something. So that's kind of what I'm working with. Yeah. Okay, let's go ahead and stretch this and bring it back to, let's see. Oh, it's already stretched. Okay, so I think it's fine. It looks good. So what we want to do now is do the RGB compositing. And so let me go ahead and bring in the RGB and B data. I should probably do like some sort of poll. So I wonder, have you guys, the dual PSF, have you guys used the dual PSF AstroSharp model yet? I'm going to guess that most of you have, because if you're on the live screen, you probably live stream with me, you probably have, but who knows? Yeah. So it's out. A couple of videos ago, I put it out, and there is, of course, the online version, which I don't know if I'll be able to keep going for more than like a couple months. I got some donations for it, but I think I'll probably leave it up for another month, and I'll probably take it down unless I get some more donations. But I thought I would do that kind of for the community, just to let them use the online version, because it's kind of cool. Okay, so let's see. No, 2 votes no. I'm looking forward to watching you do it. I keep forgetting to install AstroSharp for some reason. Yeah, it's I think it's cool. Learn from the master. Yeah. So AstroSharp, I mean, a lot of people use AstroSharp without stars in it anyway. But we'll show you how to do it today. So let's see. Let me go ahead and do the RGB data. And then, so I've loaded the R, the G, and then the B. Okay. Go ahead and do an auto stretch real quick and see what it looks like. Really green, kind of as expected. So you can see the reflection nebula here, I think, a little bit. I've only got 1 hour of RGB data, so I don't think that's going to come out very clear in the final image. But I mean, we'll see. We'll see what we can do. So we've got quite a bit of green. So maybe we can just go ahead and do like color calibration. We can try photometric color calibration first. If not, we'll just go ahead and align the channels first. So let's do NGC 6914. Find it. Then let's see. Hopefully this will work. We will see. It's going to flip the image, isn't it? Oh, cool. Good. Oops. Oh yeah, that's nice. This isn't nice. Some of the darks, I don't know, didn't calibrate very well. Maybe I need more darks or something. But here's the reflection nebula itself. We'll see if we can bring that out in the image. But I mean, this is nice. Probably should have cropped it first, huh? Would have been a good idea. Crop it now. Okay, so yeah, the RGB data is not too bad for an hour. I want to go back and do this nebula again sometime. Or just RGB, I think, and we could add HA, the HA data I've got, like make sure it's rotated correctly. So let's go ahead and do a background extraction. Oops. Put some points in here. On this edge seems a little bit weird too. And I'm just picking random points where I don't think there's much nebulosity at all. And then we'll do compute background. And it seems like it's done a good job with this side, but maybe this side needs a little bit better. And again, I mean, I could, maybe Graxpert, the new version of Graxpert would be better. I do have it installed, so maybe we could take a look at it real quick. But I think for now, I'll just use this and see how it goes. Yeah, it looks nice. The RBF works. I mean, when I tested the new version of Graxpert versus like the RBF method, yeah, like they were kind of similar. Like I think the new Graxpert, like with the convolutional neural networks, is really good, and it's probably better. But I think for 90% of cases, like Siril is fine. Yeah, I agree. The stars do look a little bit purplish. You zoom in. My doublet isn't, it only corrects for the R and G. The B it doesn't do very well on. And so I get a little bit of fringing around the bluer stars that makes it a little bit purple. But we'll see if we can fix that later on in processing. Because I do want to keep the star color, because the star color is not too bad. Okay, so apply that, and then we will stretch this. Let's see here. I'm just thinking, do I want to do a star removal? I might want to. Yeah, let's go ahead and do that too. So we'll do this. This one we won't pre-stretch it. I think I want to stretch this one myself. And then we'll execute it. Yeah, my doublet isn't the best in terms of controlling like the chromatic aberration. It's okay. It's not like good. All right, so here we go. No stars. Do an auto stretch here. Oh, man, that looks bad. Doesn't look good at all. Maybe I should have pre-stretched it or auto stretched it. So let me go ahead and let's do it again. Let's redo it. Sometimes mistakes happen. Okay, So we've got it. Auto stretch it, just see what it looks like. Color calibration again. There we go. We're almost there. Background extraction. Well, let me go ahead and crop it. And then we go ahead and do the background extraction. Hey, James, how are you? Just doing some processing of NGC 6914. Trying to make about 4 hours worth of data look okay. Already done the HA data, and now I'm just working on the RGB. Good. I'm glad to see you're doing well. Let's see how we can get it. All right. That looks better. Yep. And like AstroSharp said, the stars are a little bit purple. So it's just something we're going to deal with in post-processing, I think. Okay. So now let's go ahead and do the stretch first. So we'll do the generalized hyperbolic stretch transformation first. And then we will put it through StarNet. Let's bring the local stretch intensity up pretty far, and then the stretch up here, and we'll see what it looks like. Starting to stretch it. Let's start to see the nebulosity come out, and then apply it. Let's go back to 1. Right, let's go ahead and change the black point a little bit. So go ahead and do a linear stretch. Bring this black point up. And apply it. So we'll go back to generalized hyperlog stretch. So let's see here. The logarithmic scale. Okay, so it's curving here. Let's try the symmetry point right here at this sort of inflection point. We'll see how things go. Bring the local stretch intensity up a little bit, and then, yeah, it's looking pretty good. Don't want to stretch it too much. Go ahead and apply it, and then maybe pick a symmetry point here. Yeah, so I think in terms of Bortle skies, this is like Bortle 656, I think. I think that's a good estimate for what it is. So an hour's worth of data in Bortle 5 or 6 skies is not too bad. Okay, do we need to bring this down at all? Let's see. Maybe, I don't know. Play around with this. See if we want it like different. And honestly, like if I were back in, I don't know, where I used to live, like Bortle 7-8 zone, I would not be able to get this data in 1 hour. It would take me like 5 hours probably to get something that looks kind of like this. That's what I would guess. So I think it looks pretty good in terms of color, in terms of nebulosity. We got a little bit of weird discoloration going on up here and up here. So I don't know if we want to do another background extraction, but I don't know if it's worth it right now because we'll be using the HA data as luminance as well. Yeah. Okay. Looks nice. You can see the reflection nebula here. So this is NGC 6914, I think. This is the reflection nebula. And everything else around it is just the nebulosity. Let's go ahead and save this as a TIFF file. So RGB. Right, and then let's remove the stars now, or remove the stars now. And now we don't need to restretch it. Hopefully this will work. We did a sky analysis a few weeks ago. I am Bortle 3 at my new place. Oh, that's nice. That's so cool. How where's the Milky Way at? Where's the core now? Where you are? Is it like when you're, is it setting when it's getting dark? I guess it's summer, right? Down in the summer down there, so it probably doesn't get dark till late. Still don't have my telescope. Oh no. Yeah, it's always hard when you move to get the telescope back up. I think I have to retune my mount because there's something going on with it. Right, so here we have this. Let's see, do we want to do let's try another background extraction just to see. So to see if we can get it a little bit better. Maybe we'll bring in a Expert, I don't know. Rain, oh no. Oh man. I guess it's not worth it too much to get the telescope out if it's always raining. Okay, let's compute the background. Oops. Let's get it here too. Points. Yeah, I think that looks better. Apply it. And then we will save it as give me 1 second. Starless. We'll save it as starless. Okay. Right. You can see that like it didn't, the darks didn't calibrate all the way out for some reason. With my CWO, there's still some, I don't know what you want to call it, ant glow or something. Okay, so let's bring up Gimp. And we're going to go ahead and open as layers all of these different files. So I've got, let me just show you real quick. Let me find it. Okay. Give me 1 second. Okay, so here are all my processed images. These are the images that Siril spit out as the final results for the RGB and the HA. And then these are the starless images. So what I want to do is just the starless, the star masks for the HA and for the RGB. So I want to open up all of these. And let's see. We do want to have image composing turned on. And hopefully it will open it up, everything up as RGB image and not just a black and white image. I don't know, we'll see. Nope, it didn't. Okay, so when it does this, like, I should have known better. So you have to open up a colored image first. So the compositing result, this is the star mask. Here's the starless one. So let's open up that one first. And we can open up the other ones as layers. Okay. Now we can open up these ones. So what has everybody been imaging? Has anybody been imaging anything? I know, James, you've had a lot of rain, which no fun. But has anybody else been able to image any targets that they like? Let's see here. Okay, so what we want to do now is line up the stars from the RGB and the HA image, which is going to be easier said than done because everything is now not aligned because I cropped everything. And so we have to, and everything is a little bit rotated. So we have to kind of figure out what we want to do. Let's see. I could put it back in Siril. I think I have to flip everything and rotate stuff, which is no fun. M33, but didn't get enough time. Yeah. I've had a lot of rain here also, and it's always cloudy. Plus the fog in my location is crazy. Yeah, I've had a lot of haze in the sky. It's not like fog, it's just like real hazy. So like even if I wanted to shoot it, just wouldn't be very good. So it's been sort of a bummer. Okay, so let's see here. Let's see if I can. It's gonna be hard to figure out where these things. So I think these two stars here are these two stars here, somewhere around here, but I can't tell for sure. So let me see if I can stretch this a little bit. Yeah, StarNet does weird things with the stars sometimes. You do the automatic stretching. Okay. Okay, so here are those stars there. And there are these stars there. So I guess it needs to be flipped vertically. So let's go ahead and link these layers, not these layers, these layers. And flip it. So layer, transform, flip vertically, and we'll see if we can line these up now. And it should have flipped everything, I hope. So now, let's move this one back down, move this one up. Oops, this one. Here we go. Yep, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's where we want to go. So hopefully with these linked, when I move this one, it should move this one as well. So I'm going to press the M key for move and then move it to the correct one. Luckily I don't have to rotate anything because doing everything in Cyrillic, everything was aligned. And the only thing that changed was that I had cropped the HA data, which makes things a little bit weird when you try and align things later. Okay, so let's see. We do screen. Hopefully the stars are in the correct spot. It looks like they are. Like it looks like there's halos around this. The stars used to be, so it looks like they're there. Okay, good. It's funky. These stars are real funky. I think StarNet messed it up a little bit. Or maybe they're just not bright enough. I don't know. Yeah, it's weird. I don't know. We'll see. We'll see what happens. Okay. The first time processing something is always like it's trial and error, I feel like. And then once you've done it once, you just know what you want to improve and you do it again. And this is the first time I'm doing it, so we'll see what happens. We're going to crop this to the selection, so we have just the RG and B data together. Let's see here what this looks like if we change this, the starless RGB data to LCH color. It's coming okay. It's okay. Still don't like those stars though. I just don't. StarNet just didn't do a good job. I don't think. Like I should have stretched it manually first. So let's go ahead and do that again. Sorry for redoing things, but it just looks bad. Okay. That's really like Siril. Here's the HA data. If you're just joining, then you know that like this wasn't quite lined up over the different nights I imaged it. So I have some field rotation issues. It happens. Should have checked the rotation of it. I had a whole video on how I didn't check rotation on some of my images. Mistakes happen. Because I'm going to crop this. There we go. Oh, well, maybe. I don't know. I don't know if it's. I've been doing this for long enough. I feel like I should not be making these mistakes anymore. But yeah. Okay, I won't apologize then. But it's just something that happened. Okay, so let's go ahead and I'm going to go ahead and do the background extraction again for this. I mean, I know it doesn't need it too much, but we're just going to do it anyway. Okay. Yeah, that looks good. Apply it. And then let's go ahead and stretch it manually this time and not let StarNet automatically stretch it. So we're going to do generalized hyperbolic stretch again. Zoom in on the histogram. Put our symmetry point somewhere on its left edge. That's probably good. And then we'll start with the local stretch intensity and stretch that pretty high. And then start moving the slider up until we see nebulosity. There we go. Looks okay. I'm going to click apply, and then we're going to bring down the black point a little bit. Let me change this back to 1. So I know exactly how much we're shifting the black point. Click apply, and then we'll go back to generalized hyperbolic stretch. Go to logarithmic scale. We see that this sort of here is like an inflection point. So we want to straighten this out. So maybe a little bit here is where we want the symmetry point to stretch out that, and then we can see what happens. Zoom in a little bit and see what's happening. Yeah, it's looking okay. Apply that and then maybe do it one more time. Symmetry point maybe there. It's too much. Here. I don't know. What do you guys think? Yeah, part of the creative process. Exactly. Yep. 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 Me being lazy. Yeah, it's a good excuse to say it's part of the creative process. I think this looks okay. Kind of got a straight line going here down. I think it's fine. And then let's go ahead and now do the star removal again. I'm going to delete those files. Let's see here. So here, just going to get rid of these. Don't want them. And then give me a second to delete the star net HA files. Okay, those are gone. And now we'll rerun this. Okay, let's see what happens. Looks perfectly stretched. Thank you. Thank you. I think it did better than the StarNet did. Hopefully it'll make the stars, like the star removal, better too. We will see though. Okay, so there's that. Looks good. Now open up in Gimp again. Hide those layers so we can see them. Okay, so we have star mask and a starless. Now, hopefully, like, okay, the stars look a lot better. Yeah, they look a lot cleaner. Yeah, I think it's good. Okay, so now what we need to do, again, is line up the stars. So I'm going to link these files so that they move together. And then move this file down, move this file down. Make this star mask for the, oh geez, I deleted the wrong one. I mean, I removed the wrong one. So give me 1 second. I'll open its layers. I need the starless compositing. I mean, the star mask for the compositing. There we go. Okay, let me just make sure everything looks like it should. I have to redo this. Not gonna lie, I really like the H alpha data. Oh, thank you. Yeah, I like it too. I think it turned out really well. I was just looking at different objects to image and I found NGC 6914 and it was very small, but the nebulosity around it was, there's quite a lot of nebulosity. And so I thought, well, it would be a good image. I mean, a good thing to just image. So that's what I did. Put the screen and see it, make sure. Okay, this is definitely a star. And it's not there now. So there's something going on here. I'm gonna go ahead and just delete this layer with the starless RGB and reopen it. I mean, it's just an easy fix. There it should be. And now, if we look at it, things should be in the right place. Yeah, okay. You can definitely tell this used to be a star. And then StarNet removed it, and here it is. So we're good. Okay, so I mean, I almost feel like this 1 hour of just RGB data is not, I mean, it's a lot better than I expected. So let's go and do layered image size. here. Then layer to image size here. Actually, do I want to do that? Probably not yet. Just make sure. Let me double check. Okay, so we've got these two linked. Bring this, no, not this one. This one down. Where are those weird stars? These ones. 1, 2, 3, 4, 5. Good. Okay, so we want to expand the canvas, I think, a little bit. So canvas size here. Let's expand it. I don't know. Something like that, just so we have everything in. We can move things where we want to, select none. And that way we're not losing any data. Okay. Okay, maybe we want to link these ones. Sorry, late. Okay, so here we go. We have 1, 2, 3, 4, 5 stars here, and the same. I think I have to reflip this. Yes, I'm going to have to flip this. So I'm going to again flip this. Layers, transform. Flip vertically. There we go. Now we're good. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and now we can move these, the RGB layers, to match the HA layer. Make sure I'm going the right way, going the wrong way. Most. I think that's perfect right there. Looks perfect. Okay. Got everything lined up again. Now we can do, now we can crop everything again. Okay, image crop to selection. There we go. Okay, so now we've got stars. What? Then crop everything. I don't know why. So let's select all. Sometimes Gimp is weird. Try it again. Image, crop to selection. There we go. Okay, so what we've got now are the HA stars, the RGB stars. Okay, the RGB nebula, and the HA nebula. All right. So I'm just going to make everything sort of a normal layer without any screen or anything. Everything should be aligned. So good. Yes, good, nice. Good, aligned, good, nice. Okay, so let's think about this. What do we want to do first? Do we want to get the nebula, the color that we want? Probably probably. Let's start there. So we have the RGB nebula. Let's go ahead and make this LCH color. And you can see for a little bit like this reflection nebula right here doesn't show up in the HA nebula. So if we make it LCH color, then we got this funky weird coloration going on. So what we might want to do is take this layer, we're going to decompose it into lab space. So let's go ahead and decompose this into lab space. And then we will take the resulting L from the lab space. You can see this is the luminance from that lab space, and it has the nebula in it. The A and the B are just the color layers. And we're going to use that and put it into the HA data. I don't know if that makes any sense. So here we go. We got this selected. I'm going to select all. So Control A for select all, and then Control C to copy it. I'm going to go back into here and move this down so we have just the HA showing. We're going to paste the L layer into it, to new layer. And then I think what we want to do is either a screen or sort of only add like the lightness, if that makes sense. Only if it's brighter to add it. So like, so light and only. So let's see what light and only does. Okay, you can see when we do light and only, it gives us the reflection nebula back in there, which is nice. But it also makes this background worse. And so what we could do is take the levels and bring this down quite a bit. But again, like the more we bring it down, the less of that nebula we're going to have. So I mean, that's one way to do it, right? I mean, we could try to make this darker, quite a bit darker. And see how noisy the RGB data is. And then do something like screen. And see what that does. So again, we get the reflection nebula back in there, but everything is noisy and a little bit brighter again. So yeah, you can see how much more noise is in here. I only have a one-shot color, so finding this process quite fascinating. Yeah, it's it's really interesting. I used to do a one-shot color too. And it's definitely a different beast, you know, like trying to do this. I guess what we could do is we could just add a layer mask, because we're really only interested in this reflection nebula here, like here and here. So we could keep it as a screen, add a layer mask. Can we add a layer mask? Come on, add a layer mask. We'll make it transparent so nothing shows through. And then we will start to layer in this mask. So we'll see. Give me 1 second. Yep. So I'm going to make this, I'm going to remove this, the HA, so I don't see it. And wherever there's this reflection nebula, I'm just going to like paint over it, kind of. So wherever I think this reflection nebula is. All right, there we go. Now we're going to blur it. Blur the mask, not any of the data. Blur the mask. Okay, and then if we make this visible again, now we've got the reflection nebula here, and I think it's fine. I feel like screen works better. Yeah, I think screen does work better, but it does make things a lot noisy. So if I deactivate it, oh, that's just layer mask. If I deactivate it, if I keep it like 100% screen, then we just get a whole bunch of noise here. So sorry, I'm moving around the image quite a bit. Yeah, I agree. I think screen does look better. And if I were going to do something like, what's it called? Like the color. If I were going to do like pure narrowband HA, like SHO or whatever, or HOO, then yeah, I would use screen to get a luminance layer for the SH and O. And you can get, all of the data as part of your luminance layer. And that's what I would do too. So this is sort of like that, except it's not quite as extreme as when I'm doing SHO. But yeah, I agree. I think screen's the way to go. Okay, so let's go up and move this LCH color. And then it is still quite pink. And there is a lot of like noise in it a little bit, but I think we got the reflection nebula in there pretty nicely. I mean, one thing we could do, of course, is just try to increase the saturation of this layer. So just take saturation and just like move it up. And that might work to make it less pink or salmon pink. That's an easy way to do it. I don't know if it's the best way to do it. I think probably a better way to do it is to, again, take this, let's make a new from visible layer out of this. So now we've got this combined, right? We've got all of this combined, and then we're going to take it back into lab space. No, maybe not lab space. We'll just do an RGB space. So let's do colors, components, decompose. And instead of lab, we'll do RGB this time. Okay. All right, and then we could take the HA, because HA is pretty red. So if we were going to use a one-shot color with this, a lot of this would come out red because of all this HA data. And we could select all and copy it. And then, I guess what we want to, let's see, this is the way we want to do it. We've already got this as the red. Let's try it. We'll try it. So we'll paste it as a new layer. Again, we'll do another screen onto it. So you do it like this. So it's a little bit brighter. And then maybe we don't want it 100% of screen, right? Maybe a little bit less, but it'll make the red brighter. And then we can merge this down. You can see like how much brighter the red is. And I think we want to actually kind of tone it down a little bit, but we'll see. We'll see what happens. Because the mean of this is 0.47, the mean of this one is 0.29, and the mean of this one is like 0.29 again. So we probably want this one to be a little bit darker, or these ones to be a bit lighter. I don't know. Let's just compose it and see what happens. So we'll recompose this. Actually, we'll do compose, because it's going to, like, Gimp isn't going to know that like this red channel is still the same red channel because we combined it with another one. So I just have to compose it. We'll see what happens. right? That's a lot redder, a lot redder. So let's see. It's not quite as pink. So we can take this one, copy it, paste it to new layer, and we can compare the different ones. I don't know. It might be okay. Bring down the lightness though. I mean, it's too bright, I think. Maybe it's a little bit too saturated now. Very red. I don't know, does it look good? Super saturated like that? You tell me. I don't think it looks super good. But then again, I'm not the best judge sometimes. So let's try with the stars. Very red. It's very red. Super red. Contrast looks good and it doesn't seem too saturated. Okay. Yeah. I think it looks good. I think there's too much red in the background here. So like I think we need to like tone it down just a little bit. So let's try toning it down. Go to curves. Try and do it with curves. Let's go to red. I don't know. What do you think? Looks good to you too? Looks okay. Looks okay. I think it's a little bit too pink still. It's a little bit weird red. I don't know. Let's try it with this one to see what we think. See which one you like better. And what we can do is we can duplicate it. And then if we think that this needs to be a little bit more saturated, we could do that too. So we could just increase the saturation. Dark area is much. Yeah, Kevin, are you talking about like the increased saturation one? Okay, it's always hard to judge here due to different monitor. Yeah, it is. It's hard to, everybody's got different monitors and everything. Okay, so we're gonna call this one 1, and this one, oops, let's call it 2. Okay, and then what I'm going to do is I'm going to end this poll. I'm going to start a new poll. Start a poll. And we're going to do, which one do you like better? And I'm just going to be 1 or 2. Okay, and I'm going to blink between them. So I've got a new poll up. And then we're going to see. We're going to see which one you all like better. And whichever one wins, I'm going to go with. So we've got 1, 2. Yeah, I'll do it. I'll keep doing it. 1, 2. Got 1 vote for 1. Well, let me think. You guys shouldn't. I shouldn't tell you the results, and you shouldn't look at the results before you do it. Just do whatever you think is the best. 1, 2. So this is 2. Going back to 1. So we're at 2. This one is number 2. It's number 1. Any more votes? Kevin, which one was the? Do you think the dark areas look better? 1 or 2? This is 1. This is 2. One, yeah. I kind of agree. I think this is a little bit clipped. It feels a little bit clipped when we do 2. I mean, it's maybe less noisy, but it feels clipped. Yeah, yeah. The one, the black seems a little bit more natural. I agree with that. I do agree with that. So, we've got 2 votes for 1. I shouldn't have told you that. I'm sorry. I feel like I'm biasing people. Yeah, despite the pinkish nebula, right? Yeah, I agree. We could try and do things like, again, increasing the saturation again, because we're not increasing the saturation of the stars. We wanted to. I mean, I don't mind a pinkish nebula, to be honest. I know some people do or don't like it, and there are different ways that you can bring out the red of it. Like we could colorize the HA, for example, and make it red. That's another way to do it. So if we duplicate the HA layer, oops, Control Shift and D to duplicate the HA layer. For example, we could take this. Let me see if I can bring it up. We could take this layer, colorize it, go to colorize, and make it red. Bring all this up, bring this down, something like that. And then we could again add that if we wanted to. Let's see, which one would we'd add it to, like this visible one, right? So here we could like do something again, either a screen or just another color layer or something, and then we would have to tone it down a little bit. We wouldn't want this much red, but it would make it more red. The problem is we'd have to like put in a mask for that reflection nebula again. I'm not sure I want to do all that stuff. So yeah, yeah, yeah. I kind of like. I don't mind pinkish, a little bit pink in the nebula. I'm fine with it. Okay, so now what we want to do, we've got the nebula, we've got the stars, the colored stars, and we've got the HA stars, which I think look a lot better in terms of their size than the RGB stars. So if we blink between the two, like these ones are just huge. So what we can do is we can take the HA stars and use it as a star mask for the RGB stars. So I'm going to go ahead and deselect all of these just so we can see what we're using as a mask. So this is going to be our mask, right? So I'm going to do Control A to select all, Control C to copy it, go to RGB stars. I'm going to create a layer mask. Okay, I want it to be, doesn't matter, right? We're copying things in there. So make sure that this mask is selected, Control V to click in the HA stars, and then we want to anchor that layer into it. And then what we can see is, look at that. Like we've got color in the stars, but they're only as big as the HA stars are. Now, we might want to bring out a little bit more of the color. Right now, they don't look too natural, right? These don't look all that natural. So I'm going to maybe stretch the star mask a little bit. So again, making sure that this RGB star mask, not the star layer, but the star mask is selected. And then we're going to stretch this a little bit, maybe to bring out the stars just a little bit more, to make things a little bit sort of less ringing around things. You can see that the stars are brightening up a little bit. And again, it's just personal preference how much you want it to go. Let me make this smaller so you can see it better, and then we'll split the view so you can see what we're doing, right? So this is what we transformed it. This is before the transformation. So we can see how much we actually want to make the stars bigger. You know, how far do we want to go with it? And I think somewhere around here is pretty good. And again, we're still a little bit noisy. It's I think I need another like 6 hours of data on this to make it a really good image. But yeah, so you get HA star size with RGB colors. Yep. Yeah, thanks. Yeah, it's something that like it took me forever to realize that you could do this. Like it's one of the things that's nice about like a monochrome camera, which I guess you can do with a lot of the one-shot colors now too, because you get these like dual narrowband filters that'll keep the stars nice and small anyway. So you don't have to do all this. Maybe one-shot color is just better now than monochrome in terms of keeping the star size down without, you know, with everything. Okay, so let's see how far do we want to go with this? Okay, I think that's fine. And then there we go. We've got color in the stars a little bit, and we've got small stars, which is really nice. Nice. Okay, so one thing that we might want to do is if we want to increase the saturation, I mean the color of some of these stars, like a lot of times the color of the stars is in the outer ring of the star, and like because the star itself, the center is very bright. So what we could do is we could also stretch not the star mask this time, but the actual stars. And maybe I'll duplicate this layer just in case I don't like it later on. So I have an actual copy of it if we ever want to go back to it. But like we could stretch the stars and then like increase the saturation of those stars and then blur it. Okay, so we've stretched that a little bit so you can see kind of before and after on this side. Maybe we don't want to stretch it that much, just a little bit. And then we can increase the saturation like a bajillion times. Oh, sorry, wrong one. And then blur it a little bit. Once we're done, we'll just blur this a little bit and it'll make everything kind of like pop. So let's go ahead and I'm going to press Control F to keep increasing the saturation multiple times. Again, this is just personal preference. You don't have to do this, but I don't know. I kind of like to experiment. You can see like this layer is getting really like super saturated. Too much. Yeah, too much. Let's go back. Because we're getting all this saturation bleeding in. Okay. And then let's just blur it just a little bit. Filters blur. Gaussian blur. Okay. I think it's nice. Got a nice little nebula going on here. And again, if we wanted to, we could take this star mask, take the levels down on it, bring those stars down, control it separately if we want to. It's a good effect. Okay. All right. I think we're almost there. I think I do want to bring it into AstroSharp and AstroClean. So I'm going to go ahead and export this as a TIFF file. Let's see here. So what should I do? What should I call this? Like almost finished? And then I'm going to have no compression. I don't think we need to save layers. Should probably flatten it first too, because if it's not flattened, so let me go ahead and save this sort of as So we can just save it. And then we will do a new from visible, copy this, paste it in here. So we have it, and we'll flatten this just to make sure that there's no alpha channel, because AstroSharp will not work if there is an alpha channel with it. We'll export it again. We'll export it as, 1 second, to find the right folder. And then we'll open up AstroSharp and do it. Just find AstroSharp where I've got it, actually. Just open it up straight from R. That'll work, won't it? Okay, here we go. All right, so we've got it open. I'm gonna go and browse, find the file that I made. I'm still trying to improve AstroSharp, by the way. And I think I'm on the verge of making it kind of really good, but it's really hard. It's really hard to make it better than it is without going into like convolutional neural networks, which is what I'm trying to do. So it just takes, those neural networks take a long time to train, and there's a lot of error that goes into it. Okay, so we've got this. Let me show you what I've got. So I've saved it as sort of almost finished. I'm going to go and load it in here. It should just be a preview at this point. Oh my gosh, what is going on? Don't understand why it's not in color. Okay, give me 1 second. I don't know, did it like? Give me 1 second. I don't know what happened. I don't know why it's not in color. It should be in color. Sorry. It's weird. Yeah, real weird. I don't know what is going on. Let me try it from another version of it. Give me 1 second. Sometimes it takes a while to open, or it doesn't want to open. Here we go. Okay, let's try again. Hmm. star mask's working. The preview is not showing up in color. I don't know why. I don't know why it's not showing. It's like, it's so weird. It's so weird. Never had this happen before. Weird. Try again. Maybe there's some save layers, maybe. Maybe it wasn't. Maybe that's what was going on. Let's try again. Yeah, okay, there we go. I guess it was save layers, not clicking that was the wrong thing. Okay, so let's see. So we've got the star mask. I think we want to keep the star mask just to make sure that it's working. And I think we're getting a little bit too many false positives here. So we've got a star here and a star here, which corresponds to these two stars. But we've also got a lot of stuff around it that aren't stars. Like this isn't part of the stars. Like it's probably fine, but we can increase the sensitivity to try and mitigate that. There we go. Increase the sensitivity, and now we've got fewer false positives, and I think it's fine. We could even do a little bit more if we wanted to. And there we go. See, now we've only got stars. If we want to take this blend down a little bit, we could make the stars a little bit brighter. I think that's fine. Like something like this. And we just go around the image and make sure that it's working. So we've got 2 stars here, 2 stars here, and it should work. So we can go back to dual PSF slider now and then see what things look like. Okay, so right now this is a PSF of 3. The stars look like they have a little bit of ringing around it. So we could actually move this down. And that makes sense because we're using the HA star image where the stars are small anyway. So like any amount of sharpening of the stars is going to like kind of make it too sharp because we're starting with very small stars. I don't know if that makes any sense. In general, like you can't sharpen stars as much as you can a nebula. And so you want to make sure that like you're not overdoing it. So just update the sliders again and see how that affects stuff. Okay, so compare like this star here to this star here. There may be a little bit of ringing, too much ringing. So we could bring this down a little bit farther if we want to. Could take it to 1. There, I think that's fine. I think it's okay. If we wanted to, we could really try and sharpen this thing quite a bit. We could just see what happens. We'll see. Huh. Make this less sensitive. Maybe this is something we need to do. Getting too sharp. We're getting ringing around the stars now. Bring down the feathering just a little bit. See what's happening. Okay, so all except that star, it looks pretty good. Just try the different parameters here to see what's happening. Make sure we're covering the stars. Yeah, not enough feathering. So you can think of the feathering as sort of like a star ringing type thing. There we go. We're doing good. Yeah, I think that's good. I don't know if we want to go all the way to 8. Or the, oh, am I stupid? I think I'm, yes, I've mixed this up. I don't want 8 for the stars. That doesn't make any sense at all. We want 1 for the stars and 8 for the DSO. I was like, this doesn't make any sense. It's too late. It's like 12:30 where I'm at. So I'm getting a little bit brain dead. Let's try this again. And then, yeah, there we go. There we go. And then what we want to do is probably bring this back down. Yeah, there we go. That looks nice. I mean, it doesn't look nice. I think this is too sharp. The nebula is too sharp. We don't have enough S and R in the nebulosity to make it this sharp. So like what I said about like you can sharpen the nebula more than the stars, it's true. But if you don't have like the actual, what do you call it, like the SNR for it, then too much sharpening is bad. Okay, so the parameters I'm using with this, like the default parameters, the 9 was a little bit too high for this one. So meaning like it wasn't stretching the gray areas enough. So let me show you what that means. So it was, I think the default is like 98, 9, 100, 5. We update the sliders. You can see that there's some ringing around these smaller stars here, which means that like the model that is used to sharpen the nebula is also sharpening this part of the stars. So what we want to do is make that part here the part that the model that sharpens this is part of the stars. To do that, we bring this line to the left. To bring that line to the left, we decrease this first blend parameter. So we'll take it to 4, and then, and there we go. Like, we're good. there's no ringing. It was gone for quite some time, I think. Did I miss something? Actually, so let me show you what we've done. We have combined the RGB and the HA data. We masked in the reflection nebula here, and then through different steps, quite a few different steps here, and then we're bringing it into AstroSharp, where we're using a dual PSF model first to try and sharpen things. I was explaining that, like, you know, we can bring this all the way up to 8, but I don't think we have the signal to noise ratio to justify that here in this image. Like the SNR is like the most important thing, I think, when we're thinking about sharpening an image. Like if you want to really sharpen an image well, like you need good SNR, and so we just don't have it. And so we're going to bring this back down. So maybe something like 4, and we'll see what happens. So yeah, it's getting pretty noisy. What we might want to do too is get rid of some of this color noise. I think that might be a good idea. So before we bring this, we're gonna redo this. Let's just redo this real quick. So we're gonna resave this again. I'm sorry this is taking so long. I didn't plan it to be this long, but like processing always takes longer than I think it does. So I'm gonna take this colors components and then decompose. We're gonna bring it into lab space again. Lab space is one of the best things ever. So we've got this here, the L, the luminance. All this color stuff is really noisy. You can see like the A channel and the B channel are just super noisy. And I mean, one thing we could do is just add a blur to it or whatever. So we do a Gaussian blur, and I think at some point I want to do this in AstroSharp. It's just like do something like this. It's just clean up the A and the B channels automatically. I think that would be a good feature. Okay, so we can blur it pretty well and get rid of that noise. We do the same thing here. And then we can recompose it. So let's do colors, components, recompose. We can see what happens. We might have lost, might make things a little bit less saturated. I don't know. But let's just make sure it happened. It recomposed everything. Let's zoom in and go back. Yeah, you can see how much less color noise there is in the image now. It's good. We might have lost a little bit of color on the stars. I'm okay. I'm okay with that for now. I mean, if I had more time, I might take a little bit more time to redo things, but you can see that the color noise is gone. So let's go ahead and do export this. Export this as this TIFF file. We'll replace it, and then we'll bring it back into AstroSharp. Again, make sure Save as Layers is checked. I unchecked it for some weird reason, and it made AstroSharp not work very well. Let's go ahead and reload this image in. So it's loading back in. And then hopefully what we should see is like a lot of this color noise is gone. Yep, it's not there as much anymore. Okay, all right, let's see. How much do we want to sharpen this nebula? I mean, let's find a place with stars and nebula, just so we can take a look. So we got stars here. I mean, we could try and sharpen the stars a little bit more. I don't think it'll look very good if we do that. Yeah, they're starting to get a little bit loaded when we do that. I think that's too much. Yeah, let's keep it at 1. Again, like I said, like we were using the HA stars anyway, which were very small. So it's not like we need to sharpen the stars very much. And then I think just a little bit of sharpening on the nebula itself. Yeah, I think that's okay. Just scroll around a little bit. Yeah, that's too much sharpening. Let's go back to 2.75. Yeah, I need like another good 6 hours on this, I think, to get a really nice, to be able to use, to get a good sharpening result. Let's go ahead and do it like this. I think it's fine. And then so I'm going to go ahead and click multi-core first, and then update sliders. Just so you have to do this. It's just part of the ritual of AstroSharp. Not the best programmer. So we turn on multi-core, and then let's go ahead and do full image, and then we wait. I would say not too sharp, but enough to look sharp. Yeah. Yep. Thanks. Yeah, we don't want it to look too sharp, but we want it to be sharp enough. Okay, let's see here. All right, my computer is going to lag a little bit because it's using all the cores for everything. So try and move this over so you can see that my CPU is pegged at 100% right now. So it will probably take, I'm guessing about 2 minutes to do this. And then we can clean it up in Astro Clean. Take another 2 minutes. So anybody doing anything for the holidays? Taking some time off if you work, maybe. Hopefully I'll get some time off, be able to stay up all night imaging stuff. I'm hoping it'll be like nice, as little as possible. Yeah. 3 weeks off, nice. Yep. Be taking, I could take probably 3 or 4 weeks off if I wanted to, but I think I'm probably going to take 1 week off and then save some time off for the eclipse when it comes around. I have nothing in mind for the holidays, just being in my home, I guess. Yeah. Yeah, that's same with me. I think my plans for the holidays are um spending some time with my kids. Got 2 kids. And then doing some astro imaging if I have a chance. Being able to like actually like stay up and monitor things and sleep in the day, it's nice. Right. Waiting for AstroSharp to finish up. We'll take it into Gimp, I think, once it's finished, and then we'll compare. Is it too sharp? Not sharp enough. And then we'll put it into Astro Clean. I used to spend so much time like trying to sharpen things with like wavelets and high pass filters and everything, and it would really screw up the background of my image. And so like one of the main reasons I thought about like making this program is I wanted something that would be kind of good, that could do things at kind of like a more of a local level and still get a good image without messing up everything. Hopefully I get my scope set up. Yeah, that's nice. Yeah, I hope so too. Portal 3's skies with no rain, right? That's what we're wishing for you, James. Portal 3 skies, no rain. And like get the scopes up and I think it'll be really cool. So I look forward to seeing your images once you get the scope up. If you have, if you get them up. I'm so impressed by how far the tool has come in such a short time. Yeah, me too, especially since I work full time. And this is sort of like a side project, but like I don't know, you get like bouts of inspiration, like you're just thinking about. I mean, like at first it could only do black and white images, right? And you just loaded the image in and it did whatever it wanted to, and you got a black and white image out. And I was thinking, okay, like how can I make it do color images while keeping the same model, right? And and it came to me like, well, lab space is the best space. So I kind of used something like lab space to like sharpen the luminance layer and recombine it with the RGB. And then I was like, well, if I want to control the sharpening, like how much it sharpens, what can I do? And I was like, well, just repeat the models like 27 times, and then you'll get 27 models with 27 different sharpening, ways to sharpen, like from not sharpen too much, sharpen a whole bunch, and that'll be good. And I was like, okay, that's nice. And then people were like, well, the stars don't look very good when you do it sometimes. Like, this is true. You have good points. People like you are smart. And so it's about to finish. I'm just checking. It's in about 2 seconds. It'll probably pop up. But I was like, okay, let's try and figure out how we can how we can do the stars and do everything separately. And so it's really cool. And so like right now I'm thinking, well, okay, how like I kind of understand how Blur Exterminator works, and it's a lot different model. Like the model is extremely different. It's from what I understand, what it's doing is trying to calculate the PSF of certain regions of the image, and then it does like a traditional convolution on that based on the convolution, like the convolution it processes. And I think that's a very complicated way of doing it, but it's a very good way of doing it because you get a very good result. And so the next step is, I don't know if I'm going to be able to do it like that, but like I've been looking up into like convolutional neural networks and how to like use that. And I think a convolutional network will be better, but it's going to be a lot different of a program. So we might have to call it something else. So we might keep this one as like AstroSharp, and the other one like Deep Sky Deblur or something, because it's actually, I don't know, just make something else. Okay. So yeah, thanks James for saying that. I'm sorry, I'm getting on tangents. Let's let's go ahead and we'll save this one as a sharpened image. So just sharpened. And we'll bring it into Gimp and we'll just compare it, because I don't know if we have the signal to noise ratio to really have a super good image here. Let's try it. Open as layers. We have, where did I save it? Oh, here. Sharpened. We'll blink between the two. All right. Okay, the stars are sharper. There's not quite so much ringing, I don't think, as like if I had sharpened it with a 2.25 for everything. Okay, so the nebula was sharpened at 2.25 from what I remember, and the stars I think were just at 1. So it did a little bit of sharpening of the stars. You can see they're smaller. And then there is quite a bit of sharpening of the nebula. And again, like the signal to noise ratio is not that high on this image. So we do get a lot of sharpening of the noise itself. But I think from a distance, it looks better. So this is sharpened. This is unsharpened. Sharpened. Like the darks are a little bit darker here. Unsharpened. Sharpened. It's subtle. It's subtle. And we just need more time. Just need more time on this image. From far away, I think it looks nice. Zoom in, you can definitely see that it's very noisy. So let's go ahead and bring it into AstroClean again. So what we want to do first, let's change it back to single core. Let's go to preview. And then we can bring it into AstroClean so we don't like mess up stuff. Oh, I didn't update the sliders. Oh, that doesn't matter. Okay. I'm gonna go ahead and do the sharpened image now. We'll bring it into AstroClean and then we'll see what happens. Okay, so for AstroClean, the only slider that matters is this aggressiveness slider and the chunk size slider, but like the chunk size slider doesn't affect the output really. Okay, so I mean, let's see. I don't know if we want to update the sliders and see what 75%. See what happens. Okay, so it's very, yeah, it smooth things out quite a bit. So if it was at 100%, do it there, see what happens. Yeah, it's very, very little noise, but the detail, maybe the detail is removed a little bit. And so maybe we don't want all of that detail removed. So maybe we don't want 100% of the aggressiveness. But I think you can see the difference, right? Like this, very noisy. This, not so noisy. but I think it's a little bit too much. So let's go and update the slider scan. We'll do it at 65%. Yeah, it's probably good. Just try it. Try multi-core, update sliders. And then once that's done, we'll click on full preview, full image. And then we wait. Yeah, definitely see the difference in that. Yeah. Yeah. There are better ways to do sort of cleaning up an image. Again, but so yeah, my computer is definitely lagging now with the multi-core processing. We're again at 100% of GPU, or CPU, I mean. If I could get GPU to do this, that'd be a lot faster, but I don't know how to do that quite yet. I guess we could have done it at 100% anyway and just layered it in. Probably would work too. Right, I guess we can end this poll because it's finished. Anybody have any New Year's resolutions? Do anything for the new year? New Year's resolution of doing more astro imaging. Okay, so because CPU is nothing in particular. Yeah, me neither. Got some family coming down, which would be nice. Nephew coming down, sisters. It'd be good to see them. So it says error, YouTube is not receiving enough video to maintain smooth streaming. As such, viewers will experience buffering. Hope nobody is experiencing buffering. The image isn't moving on the screen though, so hopefully it won't be too bad. I have some friends coming to visit between Christmas and New Year's. Cool. It's a good time to have people visit. All right, here we go. We're almost there. It's almost finished. Yeah, it has. There we go. Got it. Nice. At the resolution drop, but it's back to normal now. Okay, good. That's good. I think that's because of my CPU. Okay, we've got this file down. And then we will call this one the clean. I've got to look at that M dataset. That's Carry M, I think, on the Astro Imaging channel. I've got to look at all those stuff. Okay, so let's go and open as layers the clean version. And we'll compare. Okay, from a distance, it's hard to tell. Toggle it. I can tell that there's something that is smoother. Zoom in, I think it's gonna be most obvious. So here's the clean version. Here's the sharpened version, just the sharpened version. Here's the original. So original that we had processed, sharpened version, you can tell the stars are a little bit smaller, maybe a little bit sharpener, and then we clean it up. And then you can see like a lot of the noise is gone. Man, I wish I had another like 6 hours on this target. It turned out so well, but it would have been great. Do you have PixInsight? No, I don't have PixInsight. That's why I made AstroSharp and AstroClean. But yeah, I don't. We can go back into Siril and try and remove some of the screen noise, I think. Let's try and do that. So let's go ahead and export this as, actually, no, we don't have to export it. We've got it. So let's just open up the clean file. So, yeah, I know, I like Pix. I mean, I've tried PixInsight, and I think it's probably good for a lot of people, but I just like the free software. I'm a free software kind of person. Okay, I'm going to crop this a little bit. Okay, and then we're going to go ahead and try and remove some of the screen. There's some green noise here I don't like. I can see it, like it makes things a little bit browner. I don't know if you can see it on YouTube. I'm going to remove some of this. Okay, I think I did it. Let's see. Did a little bit. Good. Let's maybe do another color collaboration. I don't know. It's, who knows how things changed. Okay, let's try it. Okay, so it did color calibrate things. Do it before, after. I don't know. Now it seems like it has more green noise. Now let's try and remove the green noise again. I don't know. I don't know. Which one do you like better? Do you guys like the one before color calibration or after? A bit the bullet and bought it a few months ago. Siril is still pretty good. Yeah, I think Siril is good enough for me. I'm sure PixInsight is a lot better. Maybe one day I'll get it, but I don't know. I'm not sure. I might get it. I might not. But I'm sort of a free person, free software type of person. Like, I just kind of, I don't know. Just kind of like the free software. Okay, let's see. Let's save this. And then we'll call this like Clean plus Siril. We'll open up it. Yeah, personally, I prefer buying new Astro stuff than Astro software. Yeah, I agree. Before is better, in my opinion. Yeah, yeah. Let's check it out real quick. I think you're right. I think before is better. It's layers, Clean plus Siril. Figure out how it flipped the image real quick because it flipped everything. Let's try layer. I did crop it a little bit, didn't I? Okay, so this is the before. This is the after. I think the before is good. So yeah, I think that's it for now. I think I'll probably do this a couple more times. I always like to process things like 3 times. Like, okay, this is good, but I don't like this and I don't like this. Let me see if I can get rid of that as I process it. And usually it comes out with a better image. But this one is fine. I mean, it's only like 4 hours of data, like 3.5 hours of HA and 1 hour of whatever, 1 hour of RGB. And I think it turned out decent for the amount of data that I had. So I'm happy with it. So all right, I think that's about it for the stream. It's getting late here, and I think we've got a good first draft of this target, and maybe when it comes around next year, I'll image it and add some more data to it. Hopefully, I'll get to the actual rotation correct next time, so I don't have to cut out so much of the image. But I think it turned out well. We did get the reflection nebula, which is, I was surprised that we actually got some of that in there. And then all this nebulosity around it looks really cool. So yeah, it was nice seeing everybody again. Hope everybody has some good holidays. I'll probably be streaming again next week sometime or whatever, depending on if I have get some new data in. Been taking some images of M45. I don't know if I'll still keep doing that. It depends on how much rain we get. I've already got about 2 hours of that, which is good for that target anyway. If I get some more, then I'll process it probably online next week. And then hopefully I'll have another video about something this week as well. So got, yes, is that reflection nebula in NGC 6914? Yeah, I think it's in Seder. I'm not sure. I can't remember exactly. Let's see. 6914. Cygnus. It's in Cygnus. So I'll link it here. So Adam Block is just a beautiful image that he put. I guess he put it on Wikipedia, and it's just a great image of it, like super image. But this is the reflection nebula, and there's a lot of nebulosity all around it, which is why I chose it. So, right, I think that's it for tonight. Thank you everybody for stopping in and keeping me company while I process this image. It's always more fun, I think, to process with people that I can talk to about the process, and they can sort of give me input and stuff, and I can kind of like test out things with people. So yeah, it is a very cool region. I need more data on it. So yeah, thank you all for stopping in and keeping me company. Really enjoyed it. So hopefully I'll be able to do it next week if I have some time. So yep, good night everybody.